Namaste, welcome to GoBlights. In this final part of our disconnected OpenShift setup series, I'm going to walk you through how to deploy a fully air-gapped OpenShift cluster using the agent-based installer. We will be running everything inside virtual machine on a single Baremetal server without any internet access. In the previous part, we already prepared the mirror registry and mirrored all required OpenShift and operator images. Now, we will bring it all together using a custom agent ISO image, static IPs, internal DNS, and a local registry to build a complete disconnected OpenShift environment. If you are following along, by the end of this video, you will have a fully working OpenShift cluster that's completely isolated from the internet, just like in a real enterprise, telecom, or defense scenario. Let's get started. As I did before, I'm going to follow the same medium guide that I shared earlier. Let's start with the prerequisite first. We will go over everything that's needed from the mirror registry to the DNS setup and pull secret. Then we will quickly validate that all the configuration are in place before we move forward with generating the ISO image. So the first prerequisite, we need Relay 8 or 9 with virtualization tools installed. So let's validate that. Let's navigate to terminal. And this is our Red Hat release, 8.10. So we are already satisfying this need. And let's check if the verse is installed or not. And verse is already there. There must be some virtual machine already running. Yeah, some of the virtual machines are already running and some of them are shut off as well. The first prerequisite is satisfied. And the second requirement is we need a configure mirror registry, which we already configure as a part of this setting up the mirror registry part. So if you remember this block, and there is a video already here, you can follow that steps and this block. We already configured that using this admin and demo password. This is my registry location. So this is my registry location, admin and demo password. We can access that mirror registry as well. I want to add one more thing here. Mirror registry is configured, and we also mirror all the required images for this OpenShift release. We already mirror 4.16. There is 4.17 as a prerequisite to update to 4.18. So we're going to start with 4.16 version of OpenShift cluster first, and we'll try to update that later. Apart from this, we need a valid OpenShift pull secret, which is already available in our junk box. As a part of this installation, we downloaded that. So if you don't know how to do that, this is a section you have to download that pull secret. Just navigate to console.redhat.com/OpenShift/install/pull-secret. Then you can download your pull secret. Then you can combine with your internal registry. And this blog talking about how to do that. Then we'll create the pull secrets. And next steps, we need to configure DNS server with forward and reverse lookup entries for all the nodes. And this is what we need to do. We're going to create a agent cluster 001, and then we're going to add all of this into it. For now, I already added it. We'll just validate that one. But if you have your DNS servers, then you have to configure all of this ahead before you even start installation process. All right, so let's validate our DNS entry as well. So for this one, I'm using named. So you can check named configuration here. And I have created a zone file called bulky.ocp.local.zone. So let's open this file, var named, and that file. So this is the cluster we're going to create. We need the API entry pointed to our keep alive address, 25. We need internal address as well, which is pointed to same again. This is, if you want to expose this outside the world, this is how you access using your kubeconfig file. This should be public IPs, and this should be your internal address so that API components can communicate using this internal address. For now, everything is internal for me, so I'm going to simply use same values for both. And there is a wildcard entry for apps, which is basically an ingress route. And when we create the OpenShift cluster, OCP will automatically set up this ingress route for you. Then we need to resolve this to this keep alive the address so that when you expose your web application as a route, it will automatically create an interface with this pattern, and then it will automatically resolve to this particular IP address. so that we don't have to create this entry every time when we expose something outside. This is the setting up forward and reverse DNS entries for each master and worker node is not mandatory to actually install the cluster. OpenShift won't fail if you skip it. However, we are doing it for a few important reasons. The first reason is operational best practices. Having proper DNS entries, especially reverse lookups, IP to hostname, makes cluster administration and troubleshooting much easier later. Many OpenShift tools and logs rely on hostname for readability. The second reason is start generation. During the install process, OpenShift generate internal certificate that sometimes reference hostname. Having proper DNS resolution avoids any weird certificate warnings down the road. Third, network validation. Some OpenShift components like the internal load balancer, service discovery, monitoring rely on DNS. Having clean forward and reverse reports ensure the network layer is behaving exactly like a real enterprise environment. And the last one, future upgrades and debugging. If you plan to expand or upgrade the cluster, having proper DNS makes the process much smoother. Some upgrade checks validate hostname resolution internally. So if I have to summarize it, it's not mandatory for install, and we can always create it later as well. But it's highly recommended if you want a production grade or realistic disconnected setup. All right, so everything looking great. So you can actually validate this as well by doing NS lookup from your local machine. So this would be resolving, right? And some is valid for API int. It should resolve with that IP address. All right, so DNS is already resolving, so we don't need to worry about that now. The next part, download this OpenShift install command. And the way you can do is you can navigate to download section. This is where your download center is. Let me log into this. And then if you navigate to download section, we can see lots of tools. OpenShift install is also available there. Usually what I do is this always download the latest. So I select Linux here, and then that's a version we need. Copy that link address, paste here, and then change these values. We're trying to install 4.16. Let me check one more time. 4.16 dot. Yeah, we do have 37, 38, and then 36 as well. So we can start with anything. So let me go with the 4.16.38. So I'm going to click here and just copy that OpenShift install linux.tar file, and this is what we're going to copy. And it's the same thing mentioned here as well. So usually you have to replace this section with that version, and then we point it to that proper artifact. All right, so let's navigate to your terminal. So I'm here inside Workspace YouTube Tools. Let me curl that command. Then I'm downloading it right now. Make sure whatever version you are installing, you should have that same version of OpenShift install command as well. All right, so it's downloaded now. Let's do tar ZXZF and then OpenShift install. Let's untar that one. It has readme.md file and this OpenShift install CLI. Let's change the permission to 755 OpenShift install. Now, if I do OpenShift install version, it should show me the proper version, 4.16.38. Next, we have to download OC and kubectl, and we can repeat the same process. So instead of downloading from OpenShift install Linux tar, you can download from OpenShift client Linux tar, and that you can find in the same location as well. If you go here and then search for this OpenShift client Linux tar, you can simply download that one as well. You can repeat the same process. I already downloaded it, so I'm not going to download it, but you have to do the same process here as well. One more thing you can do to make this process easier is move that binary file to your path, use your local bin, or whatever your path is, user bin maybe. That way you don't have to worry about path resolution later. Another requirement before we proceed, we have to install this nmstate command. It requires nmstate.ctl. That is expected during installation process. And you can run this dnf install command to do that. I think I already have that one. But if it is not available, then you can simply say dnf install -y nmstate, and it should install this. In my case, it's already installed. All right, so our prerequisite is now satisfied. So let's start preparing install config and agent config to actually install the cluster. Let's look at our install config.yaml file. This file defines the cluster-wide setting for our disconnected OpenShift install. API version v1, pretty simple, it's just the config version. Base domain balkey.ocp.local. This is the base DNS domain where our cluster will live. All nodes and services will have host name like asterisk.balkey.ocp.local. Proxy section is commented out here. If you're using a proxy for external access, you would fill that in. Since we are fully disconnected and we are not setting any proxy, so I am going to remove this section for now. Compute defines the worker node. If you are setting one replica, meaning one worker node, hyper threading is enabled and architecture is AMD 64 standard x86 servers. Control plane defines the master node. We are setting 3 replicas for high availability, so 3 control plane is required. Metadata, set the cluster name. So this is what our cluster name looks like. Agent cluster 001, and this will also impact API address, internal API address, routes, and those. So any friendly name is fine, but there should not be any special characters because this is going to create the DNS record as well. So make sure there is no spaces. Anything which is not valid for DNS record, you cannot use it here. Networking configures the cluster network CIDR, machine network CIDR, and service network CIDR. Cluster network is 10.128.0.0/40, the default OpenShift pod network. This is what it looks like. Machine network is this 192.168.4.0, matching our lab setup. And service network is 172.30, the network where OpenShift services run. Network type is OVN Kubernetes, the default CNI plugin in 4.16. Platform is Baremetal because we're using virtual machine that act like a Baremetal nodes. Even if it's not a Baremetal, I'm just trying to simulate the Baremetal scenario here. You can also set it to not, which require additional work. It can be other cloud provider specific configuration as well. For now, we're deploying on Baremetal, so we're going to use that one. API VIP is the virtual IP for API server, and this is where our DNS entry, we created that before, is pointed to this record set. API and API int is pointed to 192.168.7.25. Ingress VIP is the virtual IP for Ingress, like OpenShift Web Console, any application which you expose as a routes, which has wildcard entry, which is pointed to 7.26 there. Pull secret, your OpenShift entitlement to pull the images. We already created pull secrets. We validated that as a part of prerequisite. You need to replace this with your actual pull secret. So this is where you have to download that pull secrets from. Here, this is the location of that. SSS key, this public SSS key will be injected into the nodes for SSS access later. There is no default username and password on OpenShift. Make sure you have valid SSS key. Otherwise, you cannot log into the machine later. And the default user is core. This is additional trusted bundle, very important in disconnected install. This is the CS certificate chain for your internal mirror registry.balkey.ocp.local. It makes sure OpenShift trusts your registry as a valid source for pulling images, and this is required. Or make sure this certificate is valid. This is self-signed. Without that, it's not going to trust this registry, and then installation will fail. Image digest stores, this is where we remap OpenShift image resources to our local mirror registry. As you can see it here, default is koi.io, but we map it to registry.balkey.ocp.local. So this particular release, we map it to OpenShift release. And this particular OCP dash releases is mapped to release dash images section of registry. In short, this install config.yaml file tells OpenShift who you are, where to install, and where to get everything from, including your mirror registry. This configuration is critical to ensure a fully air-gapped disconnected installation. By the way, you can use this command OpenSSL to get the CA for your internal registry, or better extract all certificate in the search chain. I usually use this command to get that one. So if you paste that here, this is what I get it, and I put that in that install config. Or you can also check with your administrator, whoever maintaining these certificates, and get the value from them. Now, let's move on to the second important file, the agent config.yaml file. This file defines the node level details for the OpenShift agent-based installer. API version v1 alpha 1, metadata name, the name of our cluster, matching what we used earlier, agent cluster 01. Make sure this is matching with your install config here, metadata.name. Additional NTP sources are committed out right now, but if you have your NTP servers, you can also pass that information. Rendezvous IP, this is very important setting, is the IP address of the first control plane node. During installation, all agent will try to connect to this rendezvous IP to bootstrap the cluster. Now, under host section, we list each node. As you can see, this is a list. Host name, this is host name, this is another worker or master, this is another worker or master. Then you keep adding like this section for each of your machine. So I have 3 sections or 4 sections at the moment, 3 for master, 1 for worker. So it's a 4 machine cluster. For each host, we have to define the host name, master 001, role of that host, in this case master. For control plane node, it should be master. And for worker node, it should be worker. This is a root device hint, and you're passing the device name as well, which specifies which device to install OpenShift onto. Here, /dev/VDA, because these are virtual machines. For your physical servers, make sure you are passing the proper device hint. Interfaces. This lists the physical network interfaces along with their MAC addresses. These MAC addresses must match the VM settings. So in this case, I'm creating a virtual machine with this particular MAC address for each VM. I'm going to iterate that process. I will show you how to do that later. For physical machine, it should be physical MAC address of that particular interface. Under network config, we define static IP addresses, no DHCP. DHCP is disabled. To make sure our cluster has predictable network, set interface type as Ethernet, MTU as 1500. You can adjust this value. If you need jumbo frame, you can set it to 9000 or something like that. It's based on your requirement, but you can also adjust that value here. IPv4 is manually configured with static addresses. IPv6 is explicitly disabled. So if you need to enable IPv6, it's better if you enable it early. We also configure DNS resolver. It tells the node to use our local DNS server 192.168.7.126. That's where our named server is located. The search domain is balk.ocp.local. So it's only search for this particular DNS entry. Finally, we define default route for each node. It points to the gateway 4.1 through the correct network interface, in this case, this one. And then this is our destination, open to public. In simple words, the install config YAML file defines how the cluster should behave. The agent config YAML file defines how each individual node should boot, connect, and find the cluster. Both files together allow the installer to create a fully automated, disconnected OpenShift environment. Once you have both files configured, place them inside your working directory, and then we are going to generate agent ISO now. All right, so I'm going to create a folder called working dir, OCP. Let's move inside. Create a file called agentconfig.yaml file. Copy the section from that blog, which is valid for my use cases. So I didn't have to do anything manually right now. Let's paste it here and do the same for install config.yaml file as well. Let's copy the entire section. So config.yaml file, paste the entire value. Now your folder should look like this. Install config.yaml file, agent config.yaml file. So we have to move one step outside and then OpenShift install, type that command. Dir should be your working directory and simply say agent create image. Before we do that, we have to do one more thing. So inside that working directory, if you remember, our install config is missing a pull secret. So this should be your valid pull secret. Without this, it will not work. So if you remember in one of the videos, it should be part of this config.json file. This is our pull secrets, which has our registry secrets as well. So I'm going to simply copy this one and put this value inside that file. Make sure you're compressing the file, and for this, you can run this command, cat that file, do jq-c dot, and then it will compress the file, and then use that value in that install config.yaml file. All right, so I already pasted that value. Since that value is secure, so I'm not showing it here. And simply say OpenShift install and run that command now. So you'll see this kind of output saying configuration has 3 master replicas and 1 worker replicas. It's using this rendezvous IP as 192.168.7.21. It's extracting the base ISO from release payload and creating a ISO image. And this ISO image, you have to load it from your Baremetal ID DAG, or if you have Pixie board or something like that, you can do that as well. All right, so ISO generation is complete. If you do tree and then working directory, use this file. So you have kube admin password, kubeconfig file, rendezvous IP, and then this ISO image. If you go to working directory, op admin password, this is what your admin password looks like. The default user is admin, and then you're simply going to use this one. And then kubeconfig file looks like this one, or we can use it to run OC command, which is pointed to our API, this value. And it's already resolving it, right? This is already pointed to that 7.25, which is our keep aligned address. So I didn't have actual Baremetal machines to run this ISO image. Technically, in your real life scenario, you basically download this ISO image, upload it from your IDRAC, ILO, whatever you prefer, and then it will automatically start registering the servers. In this case, what I'm going to do is I'll create 4 virtual machines and then load this ISO from that virtual machine so that it acts like a Baremetal installation. Since I already have a running cluster with that name, so what I'm going to do is I'll clean up this. Let me first shut down this, force off. Let me shut down all of this machine first, and then I'll delete this as well. Let me delete the ISO image because this is what we're going to create new. Let me do the same process for others as well. This is the beauty of using virtual machine. You can keep replicating or keep testing like this one. All right, so all the machines are gone. Now you can validate that using virtuali as well. So if you go here and do verse list, you don't have that machine running right now. And if you do all, that 3 machines are there, which is shut down right now. But we're going to create 4 more machines for our use cases. Let's go back to the blog and then follow this article, launch your virtual machine. What I'm going to do is I have created this variable, cluster name brace, and it has MAC address modifier. I'll explain what are those. Let's export that values first here. Just simply paste that. Let's create a folder with that cluster name, and then create a QEMU image with 200 gigabyte of hard drive for this master. Run that command. So here what I'm doing is I'm creating a folder and then opt SSD boot as well. This is where I'm going to store the boot that isn't ISO, and this is where I'm creating a hard drive as well. So if you go to this folder, you'll see there is a image, hard drive image with 200 gigabyte size. This is our QCOW image. And if you look at this opt SSD boot, there must be other files as well. This discovery is for different clusters, but this is pretty much empty right now in your case. So I'm going to copy this ISO image to this particular location. Now this blog is referencing to this ISO image. That image is not available in this particular location, which is pretty much empty right now, opt SSD boot. Let me copy that ISO image we generated before. I will copy from this location here, working directory, agent ISO, to this location, and then I'll call it, since it's referenced as a cluster name.iso, so I'll use the same name here, cluster name.iso. It's copied now. So if you check the folder, we have this agent cluster 001.iso file available. Now create a virtual machine. I'm going to run this command as it is. Let's copy that section, paste it here. If you do verse list, you'll see 1 machine running right now. Let's repeat the process for others as well. So here, this is master 2. I'm going to copy that master 3 as well, and then worker as well. So it's a pretty much same process. Only minor difference is I'm changing the MAC address modifier. So each machine should have different MAC address, and each machine should have different hard drive as well, pointed to same ISO units. So let's copy that and paste it here. If you run command verse list again, you can see all the machines are now running. And if you get that from this GUI as well, you'll see 4 machines are running right now, and you can see the progress now. So this looked like already booted. Machine is at least up. Next, I'm going to simulate a Baremetal installation scenario. Even if this is, I'm saying air gap, machine can still reach to internet, and I don't have any firewall sitting right now. So what I'm going to do is I'm going to delete these default routers from each machine. These are the IP addresses for those machines, 21, 22, 23, 24. So what I'm going to do is delete that IP address one by one, or default route one by one. So I'm going to do this one here. This is deleted. Let's repeat the process for others as well. 22, we have to do for 23 as well. It's just we're trying to simulate the disconnected installation. This is not required, by the way. It's just a hacky way I'm trying to do that right now. All right, so let's see if I can change Google from here, and it should not work, which is nice. Same for everything. This is a bootstrap. I shouldn't able to ping Google. Let's try Podman PS. Then there are some of these container already running. So the installation already started. All right, so let's move on. Again, this is not required. So don't get confused here. I'm just trying to simulate a disconnected installation. So default route is deleted. So technically the box shouldn't have internet access, but it should is still able to reach to my internal route. So everything is running internally. Now we can do this command to check whether we can. Let me run this command here. Working directory. So what I can do is OpenShift install diaries dot, and then if I check for this, we're just checking the bootstrap complete process, and log level is debug log right now. Then you can keep watching the progress here. Another command you can run is same command instead of bootstrap complete. You can wait for install complete, and then you can see further progress. It will usually take 40-45 minutes just to complete this process. All right, so we're seeing some more outputs. Say 7.25 belongs to the mesh insider and is not in use, which is okay. And 26 belongs to mesh insider and not in use, which is nice. And this host NTP is synced, NTP sync is now fixed. So you keep seeing this kind of messages. We can also log to the host, like this rendezvous IP 7.126, and check the journal log. Usually was this one. This will give you more information as well if something is failed. Let's wait for some time. All right, so I ran into one issue here. I deleted the default route and it's not able to reach to NTP server because I forget to set up the NTP server for disconnected install. So that's the reason I added the route back for now. But every images should come from the Koei registry itself, and the installations should work as it is, as we are doing for disconnected install. If you create the NTP servers, then we'll also resolve these issues. Once I add it back, you can see NTP issues resolved, and then installation process already started here, waiting for control plane. We can also do export code config, and then this out folder, and see if we can reach to this API. There is no nodes, which is okay. And I can see only assisted installer pod, which is pending right now, which is nice. Already started responding to some extent. Let's keep watching. Let's see if I can see those nodes. And as you can see, 2 of the nodes are already available now. It's ready as well. And then master 001 is not active yet. And once this is done, then we'll also see worker node. And some of the parts are already started showing up here. Let's get CEO. Let's see all the cluster operator, and there are various operator in various stages. So everything looking great so far. By the way, one thing we can do is we can go to Koei registry and to see whether the image is actually pulling from this or not. So let's check the users log. And there was a gap here. Today is April 28, and it's like repository is pulled 278 times. This latest installation actually pulling the images from this location itself. Imagine this is the same is valid for release images as well. Yeah. So all of these are pulling from here 59 times already today. Everything looking great so far. Right, so if you notice here, a bootstrap node or rendezvous node in this case is rebooted. The system will reboot now. And this is expected behavior. And here, also get nodes command now returning 3 masters. One of them is not ready, which is okay. And this is a bootstrap node. 35 seconds ago, it just joined the clusters. And then master 2 and master 3 is already ready. And there is worker 1 also joined the clusters already. Now, if you keep watching, master 01 is also ready. So this shows like this particular command is now complete, which is bootstrap complete. And then install complete is it's doing further operation. Let's see, you also get CO. And some of the operator are still not active. For example, HCD is still doing some preparation. We have Kube API server is still doing preparation, controller managers, and scheduler. So those are all the required components for master nodes. This need to be healthy. We can run OC-whoami command to see the console URL. And this URL, we should be able to access it now. Paste that URL here. All right, so we are seeing as expected, and this is our login page, kubeadmin. password is, this is where it's located, cat auth subadmin password. This is our password. So let's paste that here. And this is our OpenShift cluster already up and running. It's still doing some operation, but it's already started responding. Everything looks healthy so far. All right, so our installation complete is final. As you can see, it's printed the console URL, which we already browsed that before. Our user is co-admin, and then password is that. All right, we did it. The OpenShift cluster is now fully up and running in a disconnected year-gap environment. In this video, we went through the full deployment process using the agent-based installer, starting from configuration files all the way to bootstrapping the cluster. Everything is served locally, no external internet access needed. We did leave it for the NTP, but that's the only thing. In the next video, we will focus on the next major step, installing operator in this disconnected environment using the mirrored catalog we created earlier. Thanks again for following along this journey. If you have any questions or got stuck anywhere, feel free to reach out. Otherwise, I'll see you in the next part where we continue building on top of this foundation. धन्यवाद.